Now this video lesson is all about the distributive property. And we're going to look at the distributive property and see it as an easy way of representing the area of a rectangle. And based on finding the area of a rectangle, we'll be able to back into what the distributive property actually is, how it's used the way it is, and then finally, some extensions of it using positive and negative numbers. But once we get through the distributive property, it won't be that bad. So let's take a look at a swimming pool. And a swimming pool is a pretty basic example of a rectangle. When we find the area of a rectangle, we're looking at finding the length, which I'll represent with an L, and the width, which I'll represent with a W. So the area of this rectangle is length times width. Now, on the other hand, we can also see, let me make that W a little bit better for you. Now, on the other hand, we can split this pool into several different sections. Maybe we have a section here that's shallow water, and this is deep water. Well, in that case, the area of the pool then is just the area of the shallow water plus the area of the deep water, because we can see visually that these two rectangles add up, shallow area, deeper area, that the area of these two rectangles add up to the total area of the entire swimming pool. Now let's take a look at this. The width of the shallow area and the width of the deep area are exactly the same because they are the width of the swimming pool. But the shallow area has length 1, and the deep area has a different length. We'll call them length 1 and length 2 because we're not sure exactly what they are at the moment, but it's not important. The area of the shallow section is length 1 times width, and the area of the deeper section is length 2 times width. And the area of the swimming pool then is either this representation here, or the overall length of the pool can be represented as length 1 plus length 2 times width. And now there's something very important about looking at these two different areas of the rectangle. This area, which just says the overall length, which can be represented either by L or by L1 plus L2, the overall length times the width will give you the area of the swimming pool. On the other hand, we also have that the area of the shallow section plus the area of the deep section gives you the area of the swimming pool. So what we see is that the overall area, length 1 plus length 2 times width, is the same as length 1 times width plus length 2 times width. And I'm not including a multiplication sign here because when we have variables, we can just put the variables directly next to each other and it means multiplied. So both of these are the same thing. Now, perhaps it's easier to find the overall length times the width. Perhaps it's easier to find the individual areas. But regardless, for the area of a swimming pool, the total length times the width is the same as length part 1 times the width plus length part 2 times the width, because length part 1 times width is this area, and length part 2 times width is this area. And when we see that the areas are exactly the same, then we start to understand what the distributive property is really all about. So we're going to take a second and look at this in terms of numbers to see that it's actually true. Let's say that the width of the area is 20 feet, the small length is 10 feet, and the large length is 30 feet. Now obviously this drawing is not exactly to scale, but we'll just have to deal with it here. What we can see is that if one length is 10 feet and one length is 30 feet, the entire length then is 40. And the width down here is still 20 because it's a rectangle. So if we look at it from the point of view of length times width, then our area is the overall length, 40, times the width, which is 20, and that gives us an area of 800 square feet, because we said that these were feet. On the other hand, we can look at it as the area of, we'll use shallow and deep. We'll use the area of shallow plus the area of deep. Now shallow's area is still length times width, 10 times 20. And the area of the deep is still its length times width, which is 30 times 20. So the shallow area has an area of 200 square feet. The deep section has an area of 600 square feet. And that adds together to be the 800 square feet that we saw earlier. And this is all dependent on the idea that the two sections of the swimming pool, when you add the two smaller areas, as long as they represent the entire swimming pool, will represent the area of the whole swimming pool. And we can see that too with a pool like this. We're not going to try to find the area of this pool. That would be a bit complicated, but what's the total area of this pool? Say we didn't know how to find the area of a section like this. Well, all we would have to do is split it into smaller sections and we could find them. The area of this smaller area, which looks like it's a shallow water area, and the area of the larger area, because the two sections combined represent the entire pool, their areas combined represent the entire area. And so when we look back in numbers, we set this together with some variables to represent any number, and we'll go through an example of how that works just to see. But the distributive property means that we can take one large multiplication and it can split down into smaller ones. So with variables, and remember that variables just represent numbers. Any numbers we want them to represent, they can. In variables, this is what the distributive property says. If you have one number and you're multiplying it by the sum or the difference of two other numbers, now these two numbers need to be in parentheses. It can't be a times b all plus c. It needs to be one letter, one number, a, times this entire sum. We can actually take that a and multiply it by each of the numbers in that sum. So a times b plus a times c is the same as a times the sum of b plus c. Now, it's a little bit confusing right now. That's okay. Go ahead and still go through the video and see what we can get for some examples. And the same is true with a difference. A times b minus, because this sign is kept, a times c. Let's see that one more time in an idea of a swimming pool. And this time we'll mix up the numbers a little bit so we can make it a bit more interesting. What does this have to do with our swimming pool analogy? Well, we have to find something that adds up to, we have to find two lengths that add up to another length. And in this case, our two small lengths of the pool add up to our larger length. So 25, which is the width, times the length of the pool, we're still trying to find the area, which is 50, which is also 30 plus 20, means that instead of doing this entire thing, 50 times 25, we can break it down into smaller sections. 25 times 30 and 25 times 20. And if we do it this way, then we can easily see that the pool breaks down into smaller sections. 25 times 20 is the area of the smaller section. Maybe that's the shallowest area. And 25 times 30 is the area of the deep section of the pool, of the larger section. So we've split our total area, 25 times 50, into two smaller areas. And we can go through with the calculations and find out that they are exactly the same. 50 times 25 is the same as 1,250, and so is 25 times 30 plus 25 times 20, all of that 1,250. You can go ahead and verify that for yourself. But for right now, take that idea and look at these four distributive property questions. Now, don't be concerned by the negative integers here. Just do exactly like we know we need to do. You take the outer number, positive or negative, take all of it with it, and multiply it by individually by each of the two numbers within the parentheses. then you keep the sign in the middle and see what your sum comes up with. So even if it's a little bit unclear at the moment, go ahead and try number 1. See how it works for you and see what you can get out of 2, 3, and 4. Pause the video, and we'll be right back to go over them. Well, number 1 is our basic example of a distributive property that we saw before. In this case, our 3 is on the outside of a parentheses. And we can multiply it by the 2 inside numbers individually. 3 times 4 is equal to 12. We keep the sign in the middle. And 3 times 8 is equal to 24. In both cases, 3 times 12 and 3 times 4 plus 3 times 8 both give us an answer of 36. So in order to say that you really understand the distributive property, you would have to give the answer of 36 plus what it breaks down into. Now for number 2, we have a negative number on the outside of our parentheses. And we can't just leave the negative where it is. We have to take it with us when we multiply within our parentheses. So let's take a look at this. Again, both of these are being added together. Negative 2 times 9. And if you're unfamiliar with this, go back to the rules on multiplying and dividing positive and negative integers. Negative 2 times 9 is negative 18. Keep the sign. And negative 2 times 4 is the same as negative 8. In either case, negative 2 times 13 or negative 18 plus negative 8 gives us the same answer, which is negative 26. So again, no matter what we have on the outside of our parentheses, our negative 2 is going to be multiplied by each of the numbers inside the parentheses, and it's going to take the negative with it. Now we saw before that it works for a difference also, and if you want to see this, this is like taking the larger area of a swimming pool and trying to find the smaller section of it by subtracting away the other section. So in this case, 4 is multiplied by 11 minus 3. Well, we know that we need to multiply 4 by 11 first, which is 44. Let's say we're not sure what to do with the negative sign yet. 4 times 3 is 12. And now are we going to add them or subtract them from each other? Well, if we added them together, we would get 4 times 14, which is 56, which is not the same as 4 times 8, which is what the parentheses simplifies to if we actually do this math. So we're going to take the negative sign here and subtract, and that gives us 32, which is the same as 4 times 8. And now 4, which is the most challenging one of them, but I put it here because as long as you understand and use just the properties as they are, and keep the negative sign and keep the subtraction sign, you will be able to figure out what the answer is. Negative 5 times 8 first is negative 40. Negative 5 times 3 is negative 15. And now we're going to keep this subtraction sign. And that gives us a bit of an interesting look here. Negative 40 minus negative 15. If we go back to what we understand and know, and if you need some review, go back to the subtracting with negative integers video lesson, that when you subtract a negative, or you subtract any number, what you're really doing is adding the opposite. So this becomes negative 40 plus the opposite of negative 15, which is plus 15. All of this together becomes negative 25, which is obvious when we look at negative 5 times 5 is negative 25. So a bit of we have a few steps to go through when we talk about the distributive property, but here's all that we're doing. We're taking one number and we're multiplying it by a sum or a difference inside parentheses. And what we need to remember is that we are multiplying that outside number by anything that's in the parentheses. So two numbers B and C, whether they're added or subtracted, A is multiplied by B, A is then multiplied by C, and whatever the sign is, we keep that sign and move it in between our new products.